Welcome, everyone. We are so happy that you are here for the program AI-Powered Business Intelligence, and really how AI is shaping the future of accounting and finance. And today, as the title indicates, we're going to take a specific look at the applications for business intelligence. Today's webinar is sponsored by Oracle NetSuite and featuring a guest speakers from Myers-Holum. My name is Liz Bergson, and on the next slide here, I just want to highlight a few things that will help you get the most out of the program today. So first of all, we do hope that you will ask questions and share your experiences and any feedback from your experiences with business intelligence and AI. Definitely having that back and forth dialogue makes it fun for you and for us as well. If you want to say hi, let us know where you're joining from. We would love to give you a warm welcome. You can download the presentation slides from the GoToWebinar control panel, and there is a lot here in this deck, so I do believe that you'll enjoy referencing the slides and sharing them with your colleagues, so you can go ahead and download those from the GoToWebinar control panel. Today's webinar is 1 hour, so as long as you remain logged in for 50 minutes and respond to 3 of the 4 polling questions, you will qualify for CPE credit, and you can access your CPE certificate directly from your in-Course dashboard. I'd love to connect with you on LinkedIn, and I would certainly recommend that you connect with our speaker and our sponsor as well. Speaking of our speaker, today's program is brought to you by Oracle NetSuite. We really appreciate NetSuite's commitment and partnership on CPE webinars like this one today. NetSuite has everything you need to grow all in one place, and they support over 36,000 customers in 217 countries and territories around the world. And we'll cover a bit on NetSuite and some of the applications today, but they provide that full suite of cloud-based ERP services. They also include financials, of course, inventory management, HR, professional services, and omni-channel commerce. And all of these applications come together because NetSuite believes that with unified information, every business achieves their vision. And NetSuite has alliance partners like Myers-Holum who help companies like yours put NetSuite into practice. So we are really thrilled to be welcoming Stephen Wolf today. Stephen Wolf is managing partner with Myers-Holum, and I'm going to turn things over to Stephen. And Stephen, I'd love for you to introduce yourself a little more and tell us about the work that you and your team do with NetSuite as we get diving into the content today.
Absolutely. So it's great to meet all of you or present to all of you here today. Like mentioned, I'm a managing partner at Myers-Holum. We're a NetSuite system integrator, so we're a boutique consultancy and system implementation firm. We focused on NetSuite for about the last 8 years, and I've been implementing NetSuite and leading teams that do so for about the last 11 years now. So I started my career implementing ERP actually internally at NetSuite, and again, the last 8 years here with Myers-Holum. We've got about 400 folks in our implementation practice, and we focus really just like NetSuite does in the SMB and middle market. So, for any firms that are, in the revenue range of anywhere between $10 to $20 million up to a couple $1 billion a year in annual revenue. So that's the quick introduction on me, and I'm excited to present to you today. Our clients are using business intelligence tools, and even furthermore, some of the AI technologies in those business intelligence tools in their forecasting and finance and accounting and managerial accounting practices. So with that, I think if we're okay to get started, I'll go ahead.
Sounds good. Thank you, Stephen.
All right, great. So, we've got about an hour together today, and the goal for this presentation is to give all of you just an overview of some of the use cases primarily around BI. Furthermore, what we can do with business intelligence in the realm of artificial intelligence and machine learning, and how we can use these technologies to optimize our financial reporting and forecasting and accounting practices to make more data-driven decisions in our businesses and our day-to-day. And then again, finally, I'll tie this all together with some use cases and best practices for how we see our clients starting to leverage BI that's powered by artificial intelligence and machine learning. First of all, there's a lot of talk, obviously, and there's a lot of hype these days around artificial intelligence. And I think it's important to talk about how, this has really kind of been around, this broader topic has been around for already quite some time. What's really in the news today are large language models and chat, chat medium AI and ML. But our clients and large, small companies alike, and a lot of the tool sets that are available to us have been leveraging machine learning already for 10, 15 plus years. And so within the pillars of AI and analytics, a lot of these technologies and capabilities are starting to converge, and that's, I think, what's really making this a focus for businesses and making it exciting for businesses. But really, again, the majority of these pillars in AI analytics, in machine learning and natural language processing, these have already been around, and so these are just accelerated by recent technology developments that you all probably have seen in the news. So we're going to start off before we get into the kind of the deep content. What are the key considerations for a firm, for a company, when implementing machine learning or AI within their business intelligence?
All right, that's great. So this is the first polling question. And as Stephen said, just looking for your feedback on key considerations when implementing machine learning and AI in business intelligence. We'll give you all a little more time to answer the question. And as you can see, response D, the fourth response there, just got a little bit truncated due to the character limits. So what that is that data quality, privacy, security, scalability, and the availability of skilled data. So what are the key considerations when implementing machine learning and AI in business intelligence? And even though we had some truncation on that, as early results are indicating that you all are gravitating toward that option as the right answer, we will close the poll down and show how the results came in. So that is the correct option. Key considerations, there are a lot of key considerations. We'll talk about them today. And data quality, privacy, security, scalability, availability, those are all the focused ones. Of course, Stephen, you can comment here on why the other answers are not the right answers if you want to, but I think here we just really want to be able to focus on some of those key considerations.
Absolutely. So I think this is this was a sort of a straightforward one to start here. Obviously, we're going to be focused on all of these elements in answer D: data quality, obviously the privacy and security, but also the availability of folks that have a background in machine learning and business intelligence. So these tool sets are not yet entirely self-service. A lot of folks, 20% of you, responded here with reducing the need for data analysis. I wouldn't say that this is a consideration or maybe even an outcome of leveraging these tools, because we still need to put in the effort. I think it's a misconception that that these will increase the time that we need to put in to research and model selection and building these forecast models. I think the time and the effort is still going to be there for many businesses, but what you'll find that ML-powered business intelligence and AI-powered business intelligence can help us with is reducing the error rate, putting together more accurate forecasting, and also organizing the data that we have in ways that we wouldn't be able to do without these technologies. So the need for data analysis is absolutely still there, and the work required to put in to implementing these technologies is very much still material and significant. But what we're expecting with ML and AI, and what we're seeing our clients achieve, are being able to answer new questions with more certainty and forecast and create predictions as well with lower error rates, ultimately, improving some business decisions and the performance related to it. So let's talk about, just leveraging AI and ML for business analytics now. What are some of the tools that we need to accomplish this? A lot of packaged, ERP software and accounting software and FP&A tools already are coming these days with ML and AI capabilities built in, but many of our clients are still going through the process, and it's still important, I'd say, even for smaller and smaller companies now, to go on the journey and create a capability of having a dedicated BI platform with a data warehouse. So I'll talk about what that means a little bit later on. Oracle Analytics Cloud and Oracle Autonomous Data Warehouse, and the NetSuite tool sets that we use. Obviously, we'll talk about today because we're a NetSuite implementation firm. So those are just two examples of these tool sets. And we also need data pipelines from our third party, our non-ERP data sets, our billing systems and our CRMs, our payments providers, our gateways, our banking information. We need those data pipelines set up into our data warehouse, and to help us consolidate data from an accounting events and other relevant information from all of the external sources that we have. So these are kind of just the building blocks of what we need to be able to leverage AI and ML. I'll show just through the NetSuite Analytics Warehouse an example architecture of what this looks like. The key takeaway here is that every company, to have really a rounded out BI capability, to be able to really leverage BI to get all of the value and the benefit out of it, we need both a data warehouse and we need an analytics platform. And so you might hear these terms thrown around a lot interchangeably, but really simply what it means is a data warehouse is the place where we store all of our data from both our ERP and all of our external sources. So, financial and non-financial data is all coming together. And then the analytics platform is the place where we actually build data visualizations, write reports, and engage and interact with the output of the models that we'll talk about a little bit later on. All right, so quick stopping point here. Another poll question: how can machine learning and AI benefit my business intelligence? I want to hear from you all and our data analytics efforts. So increasing the complexity of data analysis tasks, providing improved predictive analytics and decisions, reducing the need for skilled data scientists, or just eliminating the need for data collection and storage.
Thank you. And again, on answer B, we did have a few more things there, so I want to read that off. Answer B includes providing improved predictive analytics, automated decision-making, pattern recognition, and anomaly detection capabilities. So we have about 5 to 10 more seconds. And you might sense a bit of a pattern here. The things that machine learning and AI, the ways that they can benefit business intelligence, it's a longer list than the ways that they can't. So as we get ready to close the polling question, we just want to highlight that. Okay, we'll close the polling question. Thank you very much, and share those results. So the correct answer is B, again, the longer answer here, providing improved predictive analytics, automated decision-making, pattern recognition, and anomaly detection capabilities. So thank you everyone for responding.
Okay. So I think those are the same years. About 3/4 of you answered response B. I'll talk about why the others maybe aren't necessarily the right answer here. Increasing complexity of data analysis tasks, right? We're not going to necessarily increase the complexity of what we're doing. We're still looking for the same output. We're looping machine learning and AI into our existing FP&A, capabilities and routines and tool sets. And then for C&D, what this is not doing, when we position these capabilities to clients, we're not positioning them as necessarily an easy button, right? We're reducing the need for skilled data scientists or engineers or folks that have a background in it. Training in this and education in this area at a deeper level is very important. And we see our clients that are most successful are the ones that are investing also in either enabling their teams that they have today, or expanding and augmenting their teams to have a more dedicated BI and data management capability, and also eliminating need for data collection and storage. This is actually kind of the opposite. The emergence of these technologies actually necessitates more data collection and storage and structuring. It's important now more than ever before, and it's more easily accessible now than ever before for companies that are smaller and smaller, that aren't global enterprises, to be investing in a centralized data warehouse. So let's talk about some use cases here, and these are even in some regard non-AI or ML driven use cases, but I just want to start with reviewing some common data visualizations or categories that we see our clients leveraging, and eventually even maybe augmenting with ML capabilities, or even AI capabilities. So the first is, a gross to net waterfall. I think a lot of us have an accounting background here. We know what a sort of a standard gross to net waterfall is, and what we see companies leveraging BI and ultimately ML to do is create more granularity down to a customer level and a transaction level, a product level, into gross to net waterfall, looking at the stages of profitability that we are attributing to different sales channels or product categories or mixes, those various factors that contribute to changes here even over time. And this is a very common capability in data visualization, again, that our clients are leveraging BI for. So while at the pure, financial reporting level, this information might be summarized just to a top level segment or an account code, we are leveraging BI to create more, granular allocations of these expenses and these allowances in the middle, and we're allocating those in a more intelligent way into deeper and deeper segmentation. So clients, it's important when there are supply constraints. It's important when we are expanding the way that we're selling, the types of products that we're selling, the sales channels that we're selling through. We're growing as a company in general, or we're supply constrained. It's important to be able to take deeper and deeper looks into our profitability. And a more granular gross net waterfall is one of the most common client requirements that we have, especially with products or inventory related companies, just in BI. In that same vein, deeper profitability reporting over time by, again, product category or business unit is very important, and forecasting that or trending that out in different ways across various what if scenarios is also just a really common use case. So high level, again, profitability reporting, whether it's displayed on more of a time phased format or a data visualization where we're looking at gross to net at a product level or a segment or a category or even a customer level, are really very common requirements. On the top line side as well, looking at look back at a historical data, just a growth matrix, not only how are we growing by, let's say, maybe product group, but is our growth coming from attributed to sales channels, product mix, specific products as well, finding attribution into what's really driving our growth, whether it's by product expansion or by sales channel expansion, where that growth is occurring, and then ultimately, again, forecasting this is something that is really we're commonly looking to an outside BI tool to support. So most of the data here that we're looking at, gross to net, kind of core profitability reporting, growth matrix, and then assigning trends to these. Most of the data here we can pull out of just core financial systems that our clients are using. But this is sort of level 1 BI capability, really before we get into any deep or more advanced ML or AI use cases. This is sort of a capability that I would say is phase 1 for a lot of the clients that that we work with when they're starting their journey with BI. So we're going to get into ML next, but just curious for the group here, of the 3 models or data visualizations that we just showed, which would be the most potentially useful for your business?
Here we have our third polling question up on the screen. And what would you find most helpful? Gross to net waterfall, profitability reporting, growth matrix, all 3, or sadly, none of them. I'm sure one of the 3 would probably be a very good priority, and I'm guessing all of them. Do you find that, Stephen, when you're working with companies and you're implementing? I imagine it's more about every leader wants as much visibility as possible, right? And then it's probably prioritizing, like, which one are we going to get the most value out of to start there?
Yeah, absolutely. And so, all 3, it looks like about 60% replied here so far with all 3. That's great to hear. These are, at the granular level, at the very detailed, all the way down to a product or a SKU level or a customer level. Sometimes these are complicated, or this is a capability to build this reporting that not all of our clients have. I think it's interesting also to see that the next highest response rate, 17%, responded in profitability reporting. This is something that just in the standard data model of an ERP, to allocate in a very detailed way, in a non-GAAP type reporting, fulfillment expenses, storage fees, executive and marketing overhead, to build those allocations down into a product level or into a deeply segmented level, outside of just your kind of your standard gross to net. It's very important for a lot of our customers to see this. It's a capability that they want to have, and really, a BI capability, a BI tool set is ultimately needed to accomplish that. So, this is definitely in line with our customer base. So, it makes sense to see the kind of distribution of responses here.
Very good. Well, I'll go ahead and close down the results then, and we'll be back to your slides.
Okay. Let me just, all right.
Yep, looks good. Thank you.
All right, so let's talk about some more advanced use cases just operationally before we get into the actual, machine learning models and AI capabilities. What do we need to do before? How do we build that data warehouse? How do we structure our data? What are some of the other operational use cases and capabilities that a BI tool set overall will give us? What's kind of a prerequisite for really getting to where we want to be able to leverage ML and AI? We talked earlier about how in that overall capability, a data warehouse is something that more and more of our clients are starting to adopt. And when 10 years ago, 15 years ago, maybe an enterprise data warehouse was something that only large enterprise global companies would look to implement and add to their technology roadmap. We're seeing more and more companies in the middle market and even the SMB start a journey of constructing a centralized EDW. And so the first benefit, sort of the first order capability that a centralized data warehouse provides is blending data together from multiple systems. So, if we, let's say, an example of there's an example company footprint here. We have one cloud ERP. Our company might have made an acquisition, so they have another acquired ERP. First order, kind of first thing we're going to look to do is merging the data model, let's say maybe between two ERP systems, two subsidiaries rolling up to the same parent, very basic that we're going to merge and blend that data together so that we can, have consolidated reporting. But further on, if we want to expand more capabilities and we want to start to use either accounting events or just business events or information as part of our forecasting, as part of our analytics, it's very common also to see companies integrating data from all of the other applications that they use. Very rare that companies will just use one ERP system or one business operational system today. So whether it's a point of sale or an e-commerce application, a mobile app that our customers interact with, our CRM, our customer service systems, even furthermore, a warehouse management system or an order management system outside of our core ERP, first order of business, really prerequisite to really getting on that journey of maturing in our BI capability is blending data together in a centralized data warehouse. Once that's completed, once now we have data is blended and structured in a centralized DDW, we'll also start to support our clients in implementing approaches around overall master data management. So we want to now align and unify, for example, most commonly, a unified customer master, a unified transaction master, a unified item master, a product or SKU master across all of the systems that track and that operate with those domains. So while a data warehouse or a BI tool is not a master data management tool, it's very common that as part of that journey, our clients are implementing some structure and governance and rigor around master data management, aligning data definitions across the organization. And so as a first step, that's very important, obviously, to have data accuracy in the BI and the analytics use cases that we engage on. And so, but it's something that is commonly sort of a second step, I'd say, in the overall journey of companies leveraging BI. And finally, just another benefit of constructing a centralized data model, a centralized data warehouse, is that it provides our companies what we call BI continuity as well. So we now have a centralized data model, we have a centralized unified customer master. If in the future we replace our business applications, if we replace or upgrade our CRM, or we change customer service systems, or we change ERPs, we still integrate those new systems into our legacy data models, and so we have BI continuity. We can view the same reports, we can view the same data visualizations in our centralized BI tool, and not necessarily be impeded by or have to start over again if any of our business operational systems change. So these are kind of just three operational capabilities before we really get into anything deep, or before we expand in our BI capabilities and our data analysis and visualization capabilities. We want to be able first to have the capability to blend data together from multiple systems. We need to be able to manage our master data, to unify our core transaction ledgers, our SKU master or vendor master across applications, and align data definitions in our organization. And then also we need to be able to have continuity in our data model should business applications be added in the future, or should they change. So these operational use cases, some others that we'll talk about on the left here, data archival. If we retire business systems, we still want to hold on to the data that we generate. That's very valuable. The cliche kind of data is the new oil. So if those if those systems are retired or we're no longer generating data in our operational systems, it's all still staying structured in the data warehouse. And for some firms, it's important to also be able to interact with that data, but for regulated industries or highly sensitive industries, for PII or PHI for in healthcare, we need a capability to have that data encrypted. And also on the right-hand side here, from an operational standpoint, just some use cases to think about, that might not come front of mind is if we're any machine-generated data, even in our overall application stack. So if you operate a warehouse or WMS platform, that metadata, that detailed data around picks and fulfillment and labor productivity from the warehouse is a common source system, and any other machine-generated data from automation or any other applications or tools, IoT-driven, that we use in our business and in our operations. So just an example of what that looks like, where we can blend, let's say, operational or machine-generated data. This is an example from a customer that has an outside warehouse management system, and we're overlaying non-financial data, items picked by quarter, or hours worked, where we're not, let's say, structuring that data directly in our financial or ERP systems. We're overlaying that data with financial data that we do have, such as salary or, let's say, hours paid. We're using data visualizations like this to find, points of diminishing marginal return, or sweet spots, you might say, simply in our overall productivity overlaid against cost. Same thing here, another example from a customer, the index growth of items picked productivity, the index value over time, both considering non-overtime hours and overtime hours. How is those costs waxing or waning? Where is an inflection point for us where it makes sense to continue paying overtime? And even, warehouse productivity for specific products at a product level, at a product category or a location level. These types of data visualizations and reports, if you think about it, also eventually roll back into a capability like we have, like we showed earlier, to go and provide more data and more insight into things like per product or SKU or category-based profitability. And just kind of another example here of just an overall dashboard on a more operational basis. This is not necessarily something that we would look at from, let's say, a retrospective analysis standpoint, but something that a warehouse operator, an operations manager, or even potentially a cost accountant would look at on a more regular basis, managing their costs in labor related to operating a fulfillment center or distribution center. And this type of data and dashboard would be looked at, on a more regular daily or even weekly basis. All right, so we're gonna now switch over into some more use cases around trend analysis and forecasting, and we'll get into now actually talking through some of the machine learning use cases and capabilities that we have now. A consolidated data model, we have a consolidated data warehouse, and I just want to talk through some of the questions to get the gears turning here that a business user would be able to answer, and potentially a model, an ML model, machine learning model, that would be used to answer that question. So I'll explain these machine learning models and how they're categorized sort of in the context of the types of questions that a business could answer. So the first, linear regression, a machine learning model that's been around for a long time, nothing really new or groundbreaking, but I think you all might be familiar with this type of a forecaster model. How will a change in price affect a product sales next quarter? So this is something, as an example, potentially a linear regression would be able to show between price, our independent variable, and sales, our dependent variable, allowing a business to predict sales just based on various price points. So running a what if analysis, we change price, how will it affect sales next quarter? That could be answered with a linear regression. I'll talk about some other machine learning models, and these are the names here in bold above of the ML models, and just some questions that we might be able to ask and answer potentially with a model. Now, before I get into just sort of explaining these in more detail, I do want to highlight that this is not indicative that each of these models is the only model or ML model that we could use or we would use to answer this question. In practice, in reality, we would leverage multiple models and test multiple models in order to find the most statistically significant answer or outcome with the lowest error rate over time. But just to get the gears turning again, these are some of the capabilities that our clients are using, some of the models that our clients are using, and some questions that they're asking and getting answers from in our implementation. So a logistical regression to start, unlike a linear regression, the output of a linear regression is what we call a continuous variable or a continuous answer. So that is a specific number. So how will a change in price affect our product sales next quarter? The output here being sales, a continuous number like, let's say $1 million. A logistical regression is a type of model where the outcome is essentially a binary, so a yes or no answer. This type of model is just going to give us an answer in a discrete set of outcomes. So in this case, a yes or a no. So we could also use ML models not to give us a number output, but to give us a yes or no output just between those two defined outcomes. So an example here is, will a customer purchase a product after receiving a marketing email? So we're going to input the data from the marketing email, everything else we know about that customer, and we will ask the model if a customer will purchase a product in the marketing email and get a yes or no answer. So have, as another example, time series analysis. And I think a lot of you probably have some experience with this. Again, it's been around as an ML model for a long time, but what will be the sales of a new product in the next 6 months? So we introduce a new product. We want to see just 6 months of sales forecast for that product. Quite straightforward, but absolutely still within the category and the kind of the blanket discipline of machine learning. Another model type, decision trees, which can be a multivariable, multi-output answer. Which features of our products are driving customer satisfaction the most? So let's take a list of all of the features of the products that we have, attributes of products. Let's align that with our customer satisfaction and determine within that discrete list which of those features are driving customer satisfaction the most in a rank. A random forest model is also a prediction model. Can we predict which transactions are most likely to be fraudulent? A lot of you are probably using tools, whether you know it or not already, within your payment processor or gateway of identifying fraud. Some companies will go even a step further to create their own analysis and own predictive models in these areas. So again, just another question that, let's say, a random forest ML model might answer. Can we predict which transactions are most likely to be fraudulent? So a few more examples here. Neural networks, also available within the BI tool sets that we implement within the NetSuite Analytics warehouse with our clients. Can we forecast the demand for our products for the next year based on various input factors? So the marketing spend, the season, any other information that we can accumulate, can we forecast our products demand for the next year just on all of the multiple inputs, the data that we're aggregating. KNN model or nearest neighbors. Can we identify potential customer segments based on purchase history? So this is an interesting different type of model here. So we talked earlier about logistic regression being, let's say a yes or no output, right? Just a binary output. We're getting a yes and no. We talked about a linear regression being a continuous output, giving us an actual number prediction on sales. This type of clustering model, nearest neighbors, can take an existing set of data and create segmentation for us, create customer segments based off of purchase history. So let's identify categories or segmentations of, let's say, customers or other data. And the output of this model is clustering. It's taking a list of data and putting it into clusters or categories that we can then use for further analysis. Another kind of, I'd say maybe even more interesting model that's newly adopted by companies that we use SVM, support vector machines. This is what you might find in, and we'll show this a little bit later on, in sentiment analysis. You've seen the availability of tool sets now. I'm sure you've seen in the news or just seen in product demonstrations for a lot of software, kind of a wow moment around sentiment analysis, reading unstructured data from email communication, support tickets, customer service logs from phone calls. Can we classify customer feedback as positive or negative just based on that raw text data input, that unstructured data input? This is also something that's available in BI tools, as an example, NetSuite Analytics Warehouse that we're implementing now for customers. Kind of pushing this a little bit further more, classifying customer feedback as positive or negative can help us even drive, let's say product selection, product mix. It can help us prioritize support cases in an operational way. As an example, putting the lowest sentiment at the top of the list for someone to action on. So it's both, commonly used in an operational standpoint, but identifying segment also has a lot of analytical purpose as well. In base classifier, can we predict which email inquiries will lead to a sale? Also taking unstructured data such as email or text written communication and determining whether that product inquiry is likely to convert into a sale. Obviously, the upshot here is that we're taking unstructured data and potentially now using it in our sales forecasting. So we talked, these are names of some of the models that come available in machine learning functionality within the BI tool sets that we're implementing. Again, the takeaway is that not only one model is ever selected or used. There's really not a best fit model for this type of a question. For all of these questions here, we would always look to test multiple models before, or leverage even multiple models on an ongoing basis. But outlining the questions here just to get the gears turning for the group. What questions can we ask? What model might be used to provide us an output there? We talked a little bit earlier about sentiment analysis, and I talked about unstructured data. This is an example of not support cases or phone logs from customer support or emails. This is an example of a company that is taking data from their Twitter feed and identifying the segment of their Twitter feed, using a regression to say which products are being mentioned, which products are driving positive, neutral, or negative emotion. This is also being leveraged from some of our clients in sales forecasting and other predictive use cases. So we talked quickly just about some questions and answers that ML can provide within a BI tool set. So for the group here, what are some real world examples of successful AI and ML applications in business intelligence that we've discussed today? What resonates with you all? So advertising optimization, supply chain management, customer sales prediction, or employee performance, or another kind of interesting one, geological exploration of oil reservoir modeling.
Thanks, Stephen. Excuse me. So this is the fourth polling question. We'll leave it open so you all have some time to think about that. And just to clarify, Stephen, is this one that has a correct answer, or are you looking for feedback?
Oh, just feedback here.
Okay.
Every answer is the right answer today.
Okay, good. And of course, I think our audience knows this. These questions are, the participation is what qualifies toward the CPE credit, not the right or wrong answer. But of course, if there is a right or wrong answer, we want to make sure we reiterate the points just to help you with those takeaways and having clarity there. But this has been amazing, Stephen. It was well worth the wait to have you on with us just to see like the practical applications and the diagrams of how this works and what NetSuite can do with the NetSuite Analytics warehouse. It's really phenomenal, and this is the most like up close, tangible description and examples I've seen on this topic. So I know everyone here really appreciates that. We are ready to close the polling question down, so I'll share the results, and we can definitely see very heavy towards the first three. So answer C did get the most responses, and that is the longer answer in keeping with the custom, but that's customer churn prediction, fraud detection, demand forecasting, sentiment analysis, and social media traction. So those are some real world examples of AI and ML in application. And also we can see that supply chain management caught the attention of almost a third of you, as well as advertising. Employee performance is one, and then of course geological exploration and oil, that's a little bit more of a niche, but we do have some folks who are interested in that application as well. So thanks everyone for responding. All right, poll is tucked away and we're back over to your computer screen.
Okay. So absolutely, it looks like the first three here were most heavily responded to. I think this resonates again with our customers at Myers-Holum. Even more specifically, what we work on as an ERP implementer, probably less so use cases in terms of advertising optimization, social media management. I think there are a lot of specific tool sets outside of the realm of FP&A and ERP that address those directly. And so it's not so much within the realm of accounting or FP&A that we really are working on those use cases, but B and C for sure are the most common. Supply chain management and logistics. If you think about vendor risk prediction, supply chain risk prediction, even something as simple as, will this purchase order arrive on time? Will my vendor deliver a good or service on time or completely? For companies that have the volume of data that they can aggregate, that's a pretty common question to ask and be able to answer. And there's a lot of success there, especially if we have a large number of vendors, a large volume of data. And really, like you all answered, 39% of you, the most answered C, customer churn prediction, extremely common, not only in recurring businesses, software or SaaS companies, but especially also now in even retail or products companies. Will this customer come back? Will they churn? Will their lifetime value level off, right? Or will it continue to grow? That's extremely common, and that's an interesting place for us because we can really improve churn prediction by aggregating data not only from just, let's say, our billing systems, or like if they're paying on time or their AR aging, but also from support tickets, from their sentiment when they're speaking with our account managers or customer success teams, and other sort of non-financial information. That's a really targeted use case. Even engagement metrics. If we are a software company, how are they engaging with our application? Are they logging in? All of that really is commonly going into churn prediction. And then the most common obviously being demand forecasting. Sentiment analysis goes into all of that. Social media more and more commonly is going into that for retailers and B2C companies. And for large human capital centric organizations, obviously, the least of you answered there D, but very common. Geological exploration, oil reservoir modeling, not really in the scope of what I do, but we threw that in there as just something interesting. So we did get a few of you answered there. So again, just to wrap it all up, benefits of AI or ML-driven analytics. enhance decision-making through data-driven insights. What do we need to do to accomplish that? We have to aggregate data together. We have to store it in a central place first. We can't do as much as we ever want to without a unified data warehouse or BI application. Improved efficiency and productivity, automating tasks and processes. What we discussed today was not so much operational and the controlling and financial accounting processes, but more on the analytics and FP&A and managerial side. But also AI and ML is being leveraged, obviously, in a lot of operational ways. And ultimately enhancing our customer experiences through more personalization, identifying customers, placing them into cohorts, identifying potential churn, understanding if marketing is relevant to them, understanding if our product mix is relevant to our customer base. All of that is ultimately accomplished through AI and ML technologies. And finally, some key takeaways for you all, what we're seeing our customers do and what we recommend. Take time to further explore capabilities, train and enable yourselves on the basics of machine learning and AI. Again, what we talked about today was not large language models, was not the chat GPTs of the world, was really technology that has already been around for a long time, but is being now rapidly accelerated in its adoption by our clients. Embrace opportunities for data-driven decision making. It is accessible now for many companies to be more data-driven. These technologies are a lot more cost efficient and effective. They're able to be used by even companies in the SMB segment. We see our clients now wanting to adopt those and help AI or help streamline your financial reporting. Also with AI and ML, mostly on obviously the FP&A side, but a lot of the financial reporting that we have today can be very easily enriched and learn from real world use cases. So understand that a historical look back can help also inform future decision making. So that wraps our overview and presentation today. I hope that in sharing these use cases and explaining to you and sharing with you how some of our clients at Myers-Holum are starting to leverage and AI in their business objectives, it's piqued your interest, or it's given you all some ideas about how you can also leverage these tool sets in your business and your day-to-day operations. So I'll open it up for any questions here. We've got about 6 minutes left.
Great. Well, thank you so much, Stephen. Great conclusion there. And we do have several questions. One of the things you mentioned in the takeaways is just to learn more about AI and ML. And I wondered if you had any tips for either trainings or programs or things that you might recommend someone to do if this is an area where they want to focus on upskilling.
Yeah, absolutely. There's just a lot out there, online that's, I think, accessible. I think many universities and online, education providers are offering courses and education and enablement in these areas really squarely within a business context. So I would look to your own research. Obviously, if you just want to casually learn more about it, just Googling, right? Just finding coursework on either Coursera or Udemy, whatever that may be online. But also, if you're interested, many of our employees internally and folks that we've hired have gone through 6-month or year-long certificate courses at the universities either that they attended or someone that's offering it online, and a lot of learning kind of the core, the stats or business analytics or fundamentals. Those certificate courses have really helped accelerate both folks that we work with on the client side and even our internal employees or consultants at Myers-Holum.
Yeah, thank you. That's so helpful because, we are all hearing so much about upskilling in these areas, and you've touched on like data analytics, data warehouse, predictive analytics, business intelligence. And so it's just helpful to know like, where your team internally has gone to like improve their skills, because clearly like you've been studying this and working in it for a while. So let's get to some other questions here. So Adrian had a question earlier on, and thank you, Adrian, for your patience. How do you differentiate between AI and traditional data input validation?
So in input validation, I'm assuming that you mean uh, governing or cleansing the raw data that is brought into a data warehouse or a BI tool. Um, we are in terms of I guess differentiating between the two. Um, we have seen clients leverage AI tool sets to help cleanse or structure data that they have from their various business applications and operational systems. So, I mean, Adrian, I guess an easy example of that is if we have, let's say, a list of customer addresses that are, all in a single column, right? Non-structured, where we've got address 1, 2, addressee, city, state, country, all in a single column, okay? And we want to be able to parse that out so that we can report on customers by state, by geo, by zip code, whatever that is. Maybe build a heat map. What I've seen, let's say 5, 10 years ago, would be someone in Excel running through text to columns, spending maybe a few days going row by row, cleansing customer addresses, maybe using some regular expressions or some work in Excel or some other data cleansing tool, but ultimately pretty time consuming and manual. From an input validation, taking, let's say, that unstructured data, parsing it out, cleansing it, organizing data, something as simple as customer address or a vendor address or an employee address. AI tools are able now to do that in a much almost more immediate and faster way with just a lot more accuracy. So taking that unstructured data and saying, just show me the list of customers by country, without having to parse it out manually or go through text to columns in Excel. We've seen customers leverage AI tools or data governance tools, and there are a lot of them out there that support that, to, let's say, validate the input data much more quickly. So if that's what you're asking about, input validation, getting just raw data in, an AI tool set would leverage other means, maybe even a large language model to identify or validate information like that. Whereas without AI, it's a much more manual process of data cleansing and input.
That's really helpful, and helpful to consider the question with that specific use case that you highlighted. I think we have time for one more quick question. Sharon wanted to know, and so you touched on social media a little bit. Could you briefly explain how the info, for instance, on Twitter might be imported into NetSuite Analytics?
Absolutely. So there are various means of taking social data or collecting or aggregating data from social, such as Twitter. Our consultants, our data engineers have used tools to just scrape it from a client's Twitter page. It's not always available for just an easy export or an API. And then there are also sometimes other third-party tools that we use to go and collect that data and then land it into our data warehouse that will sort of do that for us. So something that we can either hand code or we can do as a project if not available through an API or through a simple export. And also there are other third-party applications that sometimes we recommend our clients to use to go and actually grab that data and structure it together.
Very good. Well, thank you so much again. Really appreciate your presentation today, and I'd encourage everyone to connect with you on LinkedIn and just stay in touch, because these are important topics, and having someone who has the skills and the experience and also can tie that into NetSuite as an ERP and the functionality there is really important. And I think it's the way of the future, and knowing folks who have been there is just really helpful. So thank you, Stephen. Thank you to our sponsor, NetSuite. And as we close, just want to make sure you all know you can get your CPE certificates from your Incourse dashboard. The handouts for today's slides will be available there. The recording will be uploaded this evening if you'd like to share it. And we hope that you will visit Incourse.com to check out a future webinar. There's some great things coming up from NetSuite over the next few months, of course. So have a great rest of the day, everyone. Take care, and we'll talk to you all soon.